When multiplying radical expressions with several terms, we have to just remember our distributive property rules. So we learned earlier in algebra that when multiplying a monomial by a binomial, you simply need to distribute that monomial to both terms. Or if you have two binomials multiplied together, you do a process sometimes referred to as FOIL, or just distribute each term of your first polynomial to each term of your second. The similar property applies when multiplying radical expressions as well. So when multiplying example A, we would distribute the square root of 2 to both radicals. The square root of 2 times the square root of 3 is the square root of 6. And the square root of 2 times the square root of 5 is the square root of 10. And there's nothing more I can do to simplify this expression, or either of those two radicals, so it's simplified. Now let's do the same property this time. We'll call this example B, and we'll do it by distributing both the 4 and then eventually the square root of 7. So 4 times 2 is 8. Then we add plus 4 times the square root of 7. Then we have to distribute the square root of 7, so we would get plus 2 square root of 7. And then the square root of 7 times the square root of 7 is just 7. And now for this one, we can combine some like terms. The 8 plus the 7 give us 15. And the 4 root 7 plus the 2 root 7 add to give us 6 square root of 7. Let's do two more examples. The example on the left, we'll call example C. And again, we'll distribute just like we did this last time. And again, we have 2 terms times another expression with 2 terms. So 2 times 2 would give us 4. And now we have to be careful when multiplying terms that look like this. So 2 times 5 square root of 6 would be 2 times 5 is 10. So it would be plus 10 times the square root of 6. Now we jump back to our second term. Negative 3 square root of 5 times 2 is plus a negative, or you could just call it a negative 6 square root of 5. And then for our last one, the negative 3 times 5 gives us a negative 15. And the square root of 5 times the square root of 6 gives us the square root of 30. Now this expression can't be simplified any further, so we circle our answer. For our last example, we have to remember what we do when we have an expression with 2 terms that is squared. And in an example like this, we should write out this example, this binomial, twice. 6 minus 3 square root of 5 times 6 minus 3 square root of 5. And now perform the same steps we just did above. So 6 times 6 is 36. Minus 18 times the square root of 5. Minus 18 square root of 5 again. And for this one, we have to be careful. The negative 3 times the negative 3 gives us 9. And the square root of 5 times the square root of 5 gives us 5. So this is actually going to be plus 9 times 5, which will eventually be 45. We could have written that in one step and just written 45. Now let's simplify everything we can. We know that this is 45. So 36 plus 45 is 81. And when we add our 2 expressions with the square root of 5, we get minus 36 times the square root of 5.